So hello everyone, welcome. My name is Joshit Singh and welcome to Grid Up, India's largest live learning platform. So guys, how are you all? And finally we are here with the most demanding chapter or the subject. This is your railway engineering and airport engineering. So come on guys, quickly let me know if I'm audible and visible to you. Quickly. So hi Aman, dost, good afternoon. Am I audible? Everybody, kindly please. As soon as you are joining the session, do not forget to hit the like button and welcome to the smart board session of Joshit Singh. Right? After I think 9 or 10 months, we are back on smart board. So everybody kindly just share this session and hit the like button with full power because we are going to cover the complete railway and airport engineering. Come on, audible, visible, please let me know, everybody. Perfect. Alright guys, so in this session, basically the syllabus of your railway engineering and airport engineering is this much, right? And the question, the question which have been asked already from this are this much, right? So I am going to tell you this much, which is more than the required one, okay? More than the required one. So we'll just begin the session quickly. Before that, just hit the like button and share the video with every friend who need this railway engineering. If you are thinking to skip railway engineering for your gate examination, don't. Just watch this session of 2 hours 15 minutes and that is it. You do not have to study anything other than this session. That is my guarantee. Okay guys. So hi Karam, kaise hain aap? Hi Kablan. Good afternoon, those. Good afternoon. So I'll quickly introduce myself to those who are watching me for the first time, everybody. So guys, my name is Joshit Singh and I have 3 years of teaching experience. I'm MTech from IIT Roorkee, GATE multiple times qualified, and area of expertise are transportation engineering, fluid mechanics, irrigation and environmental engineering. So if you're ready with full power for this amazing session, just send me a heart sign in the comment box, everybody. Come on. And where are the people, guys? Just share the video. Come on. This is going to be very important for you all. If you are thinking that, okay, we are not going to study railway engineering, if you are preparing for your ESC, that time you can think, okay, leave it because the syllabus is too much. But here for gate examination, syllabus is not that much. You can do it, right? So good afternoon, Bhagat. Good afternoon, Ravi Teja. Navneet, kaise hai dost? Sabhi log full power se join karenge. Right, so everybody just send me a heart sign in the comment box and let's begin the session without any further delay. Alright guys, so we don't have to get into that at what time the railway has started in India, right? First train was started as a locomotive and it was not a passenger train, it was in Roorkee. No need for us, okay? In gate examination, they are not going to ask you. Till this date, the gate examination have asked 4 questions. 1 or 2 questions are from your super elevation chapter or your super elevation concept, and rest are very small chapters or very small concept. I will cover them all, okay? And the question which can be there now, that also, if you are not aware, let me tell you guys, there are a few changes also. Some revisions have happened in the your calculation of railway engineering, super elevation and all, right? We'll see all those things as well. Cool. So let's begin the session without further delay, guys. So first of all, we have to understand the cross section of the rail. So guys, are you familiar with this cross section? Everybody just quickly let me know. Are you familiar with this? Yes. Can you see here this one thing, guys, that there are these rails? Have you ever seen the rails? Everybody have seen rails, yeah, come on. And this is your sleeper. This is your, tell me, this is your ballast and this is your formation. I will again tell you guys, these are your rails, the sleeper, the ballast and the formation. These are the important components in your railway, right? In your complete rail cross section, these are some important cross sections such as your formation, ballast, sleeper, fixtures and rails. Now what are fixtures and fasteners? I will tell you in this session only, don't worry. So first of all, ballast, guys, how many of you have seen this? Can you please let me know in the comment box? These stones lying on the railway track. Have you ever wondered why these stones have lied there? Have you ever wondered that, okay, why these stones have been thrown there? Right? There will be some reason. Actually, this is your ballast and this basically provides a flexibility to your pavement. this particular railway section. Otherwise, what will happen? The rigidity can cause so many accidents and so many failures, right? So that is why, just to provide the flexibility. We are not going to go inside this. I just wanted to tell you this is the ballast. And now the first question that can be asked in your examination, till this date they have not asked this, so there are a chance that they can ask this thing. Okay, so hi, good afternoon Shivani, how are you? And everyone else, come on. The first thing, guys, the first question that can be asked, and till this date they have not asked this, the depth of ballast. How to determine the depth of ballast, guys? It is very simple concept. The depth of ballast is nothing but it is the center to center spacing between two sleepers. Have you ever seen a sleeper? If not, let me show you. Guys, these are your sleepers. These are your sleepers. These are your sleepers. These are your sleepers. There are different type of sleepers. The wooden sleeper, the steel sleeper, and the concrete sleeper. Right now, maybe you must have seen this concrete sleeper. Right? We will come to this also. What is the purpose and all. First of all, let me tell you guys how to determine the depth of ballast, because it is the first question that can be asked in your examination. Right? So it is very simple. Very simple. First of all, we are looking at, see, this is the rail. This is your rail. This is your rail, this is your sleeper, this is your sleeper. Now look at this. Now look at this properly, guys. So basically, you have to take the center to center spacing from one sleeper to another sleeper. Good afternoon, Sonuji. How are you? From one sleeper to another sleeper. The center to center distance is your SS. Is your SS. Alright, minus the width of sleeper by 2, and here you go, you have got 1 marks if this question will ask. Nothing advanced can be asked in this concept. If they will ask the depth of ballast directly. They will provide you center to center spacing. They will provide you width of the sleeper, and with the help of that you can get the depth of ballast. How many of you have got this and how many of you have doubt? Full power response. Everybody, I don't think so that you have doubt in this, because it is very simple to understand. Right? Cool. We'll move to the next concept now. So, sleeper again, no need. Fixtures and fasteners. So, suppose, as you can understand, guys, from Agra to Delhi, say for example, from Agra to Delhi, we have a railway, right? We have a complete rail here. So, how those rails have been laid there, because if suppose Agra to Delhi, it is somewhere around, I'll say 160 or 160 kilometer, right? So do we have a complete 160 kilometer length of rail? No, we don't. Actually, we join different part of rail. We actually join chotu part, right? So how to join two rails? How to join two rails? We are going to join two rails with the help of you can see here, the rail which are fixed permanently with each other, and the fitting required for this is known as fixtures. Simple as that. Okay, dost? And next thing is the arrangement which is just required for securing connection between rail and sleeper. So you have seen just now in this image that the sleeper, you can see sleeper, and on the sleeper we have the rails. How the sleeper and rails are connected? Fevicol? No. They are, do we have drilled any holes? No, we don't drill any holes. We don't drill any holes. Then how they are connected? They are simply kept at their position with the help of fastenings. Now I will show you one thing. If you have seen it anywhere, anytime in your lifespan, send me a quick heart sign in the comment box. How many of you have seen this thing already somewhere in your lifespan? Everybody. I know everyone has seen this thing. Everybody have seen this thing. Come on. Tell me. Full power ke saath. Maza. Just, I'm literally enjoying this smart board session after ages. After 10 months, I think. Right? You must have seen this. So this is known as your pendrol clip, and again it has the same job to keep the rail, to keep the sleeper and the track and the rails intact with each other, right? And along with this we have different type of things also, such as bearing plate is also there. It is also doing the same job. It is also doing the same job, right? Then this is your fish plate, okay, acting as very good, full power, very good. Now the next concept, which is an important concept. So rail, basically there are, see, initially we used to have these type of rails. So double headed rail, bull headed rail, flat footed rail, you can see this, right? You can see this, but nowadays we use this flat-footed rail only. You have seen this already in your practical life also. Now comes the important part. This was just introduction. Now comes the important part, and guys, from here, please keep your focus here. I will take your 1 or 2 hours and I will cover the complete the most important part of railway engineering. If you are going to solve the previous year question also with the help of this only 2-hour class, you will feel like they are very easy, yaar. They are more than easy, yaar. Okay, so let's talk about them. Now, what is your broad gauge? What is standard gauge, meter gauge, narrow gauge, Cape gauge? Actually, what is gauge? What is gauge? So now see here with full power, everybody, that यहाँ पे देखिए. So guys, can you see that there are 2 rails, or I'll just show you here. Okay, so can you see here? There is. When you are going to take the distance between 2 rails, center to center distance, if you are going to take the inner to inner edge, if you will take the inner to inner distance, what we are going to call it? Very simple. What we are going to call it? Everybody tell me. Inner to inner. Inner to inner. This distance is known as gauge distance. This distance is known as gauge distance. Now the problem with this is, guys, sometimes what happens, see, sometimes what happen, there is this misconception also. We are going to cover it as well. So it look like this, okay? And here it will be like this. Something like this. Okay, guys. Now the problem here is small problem is, guys, if you will see, if I try to show you a very you can say magnified image of this part, what I am going to see here, the magnified image, what we are going to see here, everybody, we are going to see that we have this type of curve like this, right? So now if I'm going to measure the distance from here, distance will be different. If I'm going to measure the distance from here, distance will be different. Then what is the solution to this? From where I have to measure the distance, inner to inner distance, I have to measure from where? So guys, there is a very easy and very cheesy concept. What you have to do is, the railway board has suggested, you have to take from this tabletop, and you have to go 16 mm. Somewhere it will be written 14 mm also. No problem. 16 mm is also correct. So below 16 mm, wherever you will come, from there you have to measure the inner to inner distance. And inner to inner distance between 2 rail is known as gauge distance. Now there are different type of gauges, as I have mentioned here also. Broad gauge, and there is this narrow gauge, standard gauge, meter gauge, right? So most of the world right now is following the standard gauge. But in India, and also the metro, how many of you have ever seen Delhi metro or any metro? Have you ever seen? Have you ever noticed that there is no ballast on the metro? Have you ever noticed there is no ballast on the metro? Everybody quickly respond. Ever, you have never seen. I know, right? I know there is, because the ballast needs maintenance. I can't do maintenance, yaar. And that is the reason why we have a limited speed of the metro. Why our metro can't run equal to Gatiman Express train speed, right? This is the basic funda. So now understand here. In India, we are using broad gauge since we have this uni gauge policy. Under uni gauge policy, what we have to do is we have to make all the gauges as broad gauge. This is the uni gauge policy which India is following. Okay, guys, why we are using standard gauge again in the metro and why not broad gauge? Because most of the places in other countries, people are using standard gauge. Now it is easier to get the components, or you can say the coaches of the train for a standard gauge, as the demand is high for standard gauge coaches and your bogies of the metro. All right, so availability is easy. That is the reason. Okay, that is the reason. So everybody, till this point, anybody have any doubt, small, big, 1 rupee doubt, 2 rupee doubt, 1 crore doubt, please ask. But if you are enjoying the session with full power, don't forget to hit the like button, and also just send me a heart sign in the comment box, everyone, because this one is important. So the gauge, this gauge is nothing but this is the track gauge. Do I have to remember the value? Yes, you have to, but don't worry, you don't have to remember all these values. This and this one you can remember. This is very simple, 1000 mm, ऐसे याद हो गया. This is the name only. Meter gauge, this is 1 meter only, right? This is 1 meter only. So these three are important if you want to remember. This is known as the track gauge. This is known as the track gauge. This is your track gauge. Now there is one more thing, guys. Do you know that instead of track gauge we have one more gauge, and that is known as the dynamic gauge. Now what is dynamic gauge? So guys, just now I have told you gauge is nothing, it is the distance, the inner to inner distance is your track gauge. But my friend, center to center distance, from center to center distance is your dynamic gauge. From here, from center to center, the gauge is known as the dynamic gauge. Gauge is known as the dynamic gauge. We are going to use the dynamic gauge very often. That is why I am already telling you this, right? Now let's move to the next concept. Oh, this is the favorite, the most favorite of all. Bhaiya, coning. What is the coning concept? Coning of wheel. Why we are doing the coning? So guys, we have seen the vehicle, like we have seen car and all, right? Car and all. So in car and all, we have seen the tire is something like this. The tire is something like this. Since I am not at my house, so I can't show you I have two cars. I have shown you, right? How many of you have seen those cars? I have one Desire and one Honda City. Not the real one, the small one I have, right? So guys, see here, the car tire is something like this. The car tires are something like this, right? But in your train, the tires are not like this. The tires are like this. The tires are like this. Why? The question arises, why? Why we are doing coning? Why not just like car we have flat tires? Why we have coning? This is the question here. Now understand, guys. So before that, you will tell me one thing, guys. Suppose I have two tires. One is having the diameter equal to small d, and one have the diameter equals to capital D, and both you can clearly see the difference. Can you quickly tell me, out of small d and capital D, who will cover more distance for one circumference length? Everybody tell me, for one circumference or one rotation, in one rotation, out of this and this, who will cover more distance in just one rotation? With full power, everybody respond, and I will tell you this coning concept like never before, and you will never have doubt that how and what was the coning of wheel concept, right? Everybody tell me with full power in the comment box, out of this and this wheel, for one rotation, who will cover more distance? It is very simple. Please tell me. I just want you people to get engaged in this, right? Then only we will have, very good. Chintan, very good. Divya, very good. Karam, very good. Shibani, very good. Ashish, Aman, full power से very good दोस्त. बड़ा वाला tire, that is the capital D tire, will cover more distance in one rotation. That is perfect answer. Now come back to the coning. So guys, whenever I am going to have this type of curve, whenever I am going to have this type of rail, can you see one thing? Can you see one thing here? This is the lateral section I have made. So can you see this one thing, guys, that the inner tire of the rail of the train, have to cover only this much distance, right? But the outer tire have to cover this much distance in same time. How is this possible? How I can design my train, or how I can design my wheels so that for the same time the inner tire should cover a small distance and the outer tire should cover the more distance. How is that possible? So this is where the concept of coning will come into the picture. somehow, if I have a small dia of the wheel on this one and the large dia of the wheel on this one, then for same rotation, I will get more distances here and I will cover less distance here, and this is the solution of my problem. So now what I have done is I have made a coning of the wheel, something like this. If it is not visible, let me show you like this also. See, right? So now what is going to happen? As soon as, guys, you will come here, the train, as soon as it will come here, what will happen? So the train will have the tendency to go outward due to the centrifugal force. Agreed? The train will have the tendency to go outward. Everyone agreed with this or not? Everybody agreed with this or not? The train will have the tendency to go outward whenever we are driving and we are turning the car in the right direction. Our body have the tendency to go in the outward direction due to the centrifugal force. That is a very simple concept. mv square by r is the centrifugal force here, right? Due to this, what is going to happen? The larger dia, suppose if this is the train ka wheel, cool. So now what is going to happen? So the larger dia will come on the rail. The larger dia will come on the rail, and the smaller dia here will come on the rail. And I have already told you that the small dia for one rotation is going to cover less distance and the larger dia will cover more distance. Agreed or not? With full power, everybody please answer. No, Vamsi Krishna ji. No, you will not lose. Correct. So this is the solution of my problem. Do I have to make any machine to do this? No, I just have changed the shape of the wheel and I have got the solution of my problem. You can see from here as well. So here the train is going inside the board. The train is going inside the board and it is going rightward. It is turning in the right direction. Can you see here? See. Can you see here? This rail have the larger dia in contact and this rail have the smaller dia in contact. So this is the solution of my problem. Now tell me, guys, anybody have any doubt in this particular concept of coning? Full power say, let me know. And the coning is done. The question arises, what is this angle? So if I will make here, if I will join it, guys, if I join it like this, then this slope is 1 in 20. This is another 1 mark question I have just covered for you. Till this time, we have covered total 2 marks, which can be asked in your gate examination from railway and airport engineering. Those who have joined late, let me tell you guys, till this point we have covered 2 marks definitely which can come in your gate examination. None other than this, nothing will come. And obviously the most important part we are going to cover, right? We are not going for ESE or something like that. We are covering for gate here. If you are thinking that I will just leave gate the railway engineering for this gate 2021, please don't. Just watch this video, 1 hour, 2 hour, that's it, finish. Right? If you are enjoying, just full power ke saath hit the like button and send me a quick heart sign in the comment box, everybody, because we are discussing this railway engineering, complete railway engineering here, right? So coning is done. Now the problem, another problem arises because of this. Now what is that problem? Understand here. I will draw the diagram again for you just for better understanding. So this is my head of department. नहीं वो तो अभिनव सर है. This is my head of the rail, right? I have just shown you guys that the tire will be like this. And as soon as the tire will be like this, can you see the contact? The contact is very less here. So what we can say? Basically, because of this guys, very small area is getting too much load. That is why it is getting a lot of stress, and that could be the reason of the failure of the rail. So how to increase this contact between the rail and the wheel? How to increase this contact? To increase this contact, what I am going to do? I will be doing cheating. How? I will simply tilt my rail only. I will tilt my rail only. लो जी लो, हो गया solution number आपका एक और. As soon as I am tilting it, the tire will be now in this much contact. Instead of that, the contact will be more here. Can you see? Can you feel the concept, everybody? I have increased the contact between the wheel and the sleeper and the rail. Yes, Shivani, we have tilted it. But how? The question arises, how to tilt a rail? How to tilt a rail? Should I go and tilt the rail and keep holding it? No. For this, we are going to use the edging concept. I am going to make the edging. I am going to do the edging in the sleeper only. How to do that? So right now I have this sleeper. This is the sleeper, which you will see generally like this. So if you want to do the edging, now this is after edging. This is after edging. Zyada ho gaya. Let me just make a little bit realistic. Now guys, this is your sleeper after edging. As soon as I will provide the edging, what is going to happen with my rail? The rail will look like this. Can you see that it is tilted? And as soon as it is tilted, I am going to see, okay, the contact has increased, and okay, how much is the edging slope? How much is this edging slope? This is also 1 in 20. One more marks added in your knowledge, and now we have covered total 3 marks for your railway in your gate examination. I will mention the marks here. Don't worry. After this concept, they will increase by 2 marks after every concept, because now the concept which are going to come, they are very important. Anybody have any doubt in this small concept, please let me know, guys. But if the concept is perfectly clear, you have got the feel of the concept, let me know in the comment box. Hi Nivedita, good afternoon. How are you? A long time no see. Where were you? Come on, tell me. Everybody full power. Set hai? Any doubt? Anybody? Small, big? Any doubt? Please ask. Set. All right, come back. Now the sleeper density. What actually is sleeper density, right? Very simple concept again, right? When I'm here, concept is already simple, so I don't have to tell this again and again. So the density of sleeper, what does that mean, guys? What does that mean? So basically, how many sleeper I will be needing? This is your sleeper density. Basically. So sleeper density actually is how many sleepers are required in one rail length. How many sleepers are required for one rail length? Right? This is your sleeper density. Now how to define sleeper density? Sleeper density is the number of sleepers per rail length. Yahi to maine bola. This is what I have said. It is specified as m plus x or n plus x. Don't go to m or x, just leave it. Where m or n is the length of the rail in meters. So what is the one rail length? Basically, this is the thing, right? One rail length, this is the thing. Okay, let me see. Someone has a purpose of flange. If there is no flange, then there's a high chance of derailment. Because I have shown you, Kiran, when there was a turning movement, the train have the tendency to move outward, and if the train will try to move outward and there will be nothing to stop it from going outward, which is the flange basically. Flange is stopping the wheel to going outward of the track. If there will be no flange, you will see the train will become car and you will start moving your train on the road, which is not the purpose, and this concept is known as derailment. that concept is a little bit painful. So that is why I'm not going to discuss it, right? So guys, basically one rail length comprise of how many sleeper is your sleeper density. Concept finish. How the question will come here, that also I will tell you. First of all, see, this is not at all important for you, that what factor, we are not here to discuss factors. Calculate the total number of sleeper required for 4 kilometer railway track if sleeper density is n+1 for a BG track. So you will get this information n+4. Okay, so n here is your one rail length. Guys, quickly let me know in the comment box what is one rail length for broad gauge. We are talking about broad gauge, I suppose. Yup, BG. What is one rail length for broad gauge? Let me know in meters in the comment box and share the video, guys. Share the video. If any friend of yours require this railway engineering concepts, you can share this video with your friend and hit the like button with full power, everybody. I will not reduce my energy and you do not reduce your focus. Be focused, not a long class. Whatever you will get, it will be worth studying, right? Come on. The one rail length distance, that means when I am manufacturing a broad gauge, when I am manufacturing a broad gauge rail, then one rail have the length of how much distance? It is 12.8. Brilliant. Brilliant. So Kabilan and Shibani, guys, that is the broad, that is the gauge. I'm asking one rail length. I have told you, if I'm going to construct a complete railway system from Agra to Delhi, I cannot just create or I cannot manufacture 160 kilometer long rail. I have to make that rail by combining different type of short rails, right? So one rail length of broad gauge is 12.8 meters. I will add 12.8 plus 12.8 plus 12.8 and such that I will make 160 kilometer of the rail, right? So one rail length for broad gauge is 12.8 meter in case of broad gauge. Broad gauge will be asked in the examination, don't worry. We are going, see, GATE examination, ESC examination, they are a practical examination, right? Where the questions will be very practical. Unlike the questions of R.D. Sharma or R.S. Agarwal, which we used to study in our 10th or 11th or 12th class. Raju bought 150 watermelon. Why, bhai? Why? Who buy 150 watermelon? What is this question? Right? So we are going to get a very realistic value. So they will be asked you BG, because in India we are using BG only, right? So N is this much, right? So basically number of sleepers in one rail length are how much, everybody? Tell me. So it will be 12.8 plus, how much is this? 4. So this is what? 16.8. Can I give 16.8, guys? Can I give 16.8 sleeper? No, I can't. So I will give 17. Right? Aisa thodi na, like we will give 16 complete and one we will provide only 0.8. This is not possible, right? So 17 sleepers we are going to use in one rail length, right? Okay. I have 4 kilometers. If in one rail length I am using 17 sleeper, how many sleeper will be utilized or how many sleepers I am going to place in 4 kilometers? Unitary method, please apply right now. Let's see who will give me the first answer. Everybody, please, full power answer. So the total sleepers will be, total distance is 4,000, right? One rail length is 12.8 and in one rail I am using 17. Answer, everybody, in the comment box with full power, please. Just solve this. I think I don't have calculator here. Okay, I'll try my cell phone. 4,000, 12.8. Is it correct how much we are getting here? Can you please tell me, everybody? Can you please let me know, guys, how many rails I'm going to use. That is 4000 by 12.8. In one rail, I'm using 17 sleepers. In one rail, I'm using 17 sleepers. How many answers? How much will be the answer? Everybody quickly respond. Answer, 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 everybody. In one rail length, I am using 17 sleeper. I have total 4 kilometers. So please check how many rail I will be using to form complete 4 kilometer of the stretch. Number of one rail, or you can say number of rail I'll be using are 4000 by 12.8. And in one rail, I'm using how many? 17 sleepers. So the correct answer will be 5313. Now, anybody have doubt? Kindly please let me know in the comment box. If you have got the feel of the concept, just send me a heart sign in the comment box. Everybody, full power. Everybody, full power. Cool. So this question will come for again 1 mark. So how many questions, how many marks we have added now? Okay, 4 marks. Total 4 marks we have already discussed, right? In just 36 minutes, 4 marks already done. Very good, Shibani. Very good, Sonu, Nivedita, Akash, Aman, Karam. Very good, guys. Correct answer. Set है. आ जाओ आगे आ जाओ. Full power के साथ अगला concept. Okay, so speed of track. So basically there is a concept of this maximum safe speed. Okay, safe speed बोल दो, या there are other terms also. So we have different formulas to get the value of your speed of track. Okay, so there are this one thing which is your by railway board. The second is Martin's formula. The third is calculated by super elevation formula, and the fourth is transition curve formula. Earlier we used to use this Martin's formula, but do we use it now? No, we don't. We have revised the complete way of getting the value of the speed. All right, we have completely changed it, and that is why we are not going to use the Martin's formula. Right? So before we enter in the horizontal alignment, we have to first understand how to get the radius of the curve in case of your railway. First of all, let me know the guys, how many of you still remember the way I have told you the super elevation in highway engineering? Do you remember that? Highway engineering, do you remember guys? We have discussed about the super elevation. Everybody, full power response. Do you remember? Very good. If you remember it, then today's session is going to be a very easy thing for you, because it is not that different from that particular super elevation. So let's first discuss about how to get the radius of the curve. So guys, suppose if we have a curve like this, right? So railway says that there is one specific chord in this particular curve, right? And that chord is the standard length is 100 feet chord. Okay, the standard is 100 feet chord. 100 feet chord is nothing, it is somewhere around 30.5 meter, right? It is somewhere around, okay, it is somewhere around 30.5 meter. Cool, right? And guys, how many of you are aware of the 6 p.m. session or our another channel that is Grade Up Civil Champion? Do you remember? If you don't know, let me tell you, there is an amazing session at 6 p.m. today on our another channel that is Grade Up Civil Champion, and it is going to be very amazing session for you. You know why? Because me and Abhinav sir are coming together to take the session, and yes, when we are together, we always bring surprises for you. So yes, we have surprise for you all at 6 p.m. We will meet you on Grade Up Civil Champion YouTube channel today, 6 p.m. All right, let's come back to the session. So we have this 100 feet chord, or you can say 30.5 meter. So obviously guys, it is going to meet somewhere here also, right? Like this. Either also. So this angle here made is, guys, nothing but it is known as degree. It is known as degree. Now how to get the value of degree? How to get the value of degree? Very simple. It is very, very simple. All right, so guys, understand here how to get the radius of the curve. So what we do is the railway suggests that it is also almost equals to 30.5 only. This is the assumption. Again, I'm telling you, this is assumption. This is also 30.5 meters. Since this distance is very small, this is also your 30.5. All right, now guys, here I am going to use, do you remember the triangle concept, similar triangle concept? Same thing is utilized here. Same thing will be utilized here. How? So guys, this small angle, which I am calling degree, divide by, what is this total angle, everybody? What is this total angle, everybody? What is this total angle, everybody? 360. 360 equals to this particular arc length is how much? 30.5. Then what is the complete length? What is the complete circumference of this circle? Everybody in the comment box respond. What is the complete circumference of this circle? Can I say 2 pi r? Can I say 2 pi r? Can I say 2 pi r? And from here you can get the value of d degree. If you have the value of d degree, you can easily get the value of radius. Correct? Yes, Julie, you are late, but it's fine. Okay, cool, sir. From here you can get the value of d. Can you quickly let me know, guys, how much you are getting from here? Let me see. I will also calculate. So this is 360 multiplied by 30.5 divided by 2 pi. This is almost 1750, everybody. This is almost 1750, everybody. From here you will get d is equals to 1750 by r. 1750 by r. This is how you will get the value of radius if you have the degree in the question. This is how you will get the value. Right? Most of the time, guys, you have to use this 100 feet chord, that is 30.5 only. Right? In case they ask you the value of, okay, tell me what is the radius if the degree is something else, or what is this value? If the chord length is 30 meter, quickly let me know what is this value if the chord length is 30 meter. Everybody in the comment box, please. What is this length if I have the chord length as 30 meter? In the comment box, please write down. In the comment box, please let me know. Let's see how much you have got. Come on, everybody. Full power. Are you enjoying the session? This also, please let me know so that I can keep up my energy like this only. Are you enjoying the session also? Wow. You know, this hot coffee. This is what I need, nothing else. I can just drink hot coffee and take the session whole day. There's no problem in that. Everybody tell me the value of this. It will be very good, Karam. Very good. Sir, circular है, pi d होना चाहिए. अबे यार. Sir, what is 2r? What is 2 into radius? Sir, what is 2 into radius? That is d only, na? That is pi d only, na? What is this confusion? Very good, yes. If you will take the chord length as 30 meter, guys, then this will become 1720. This will become 1720, right? This will become 1720. That is correct. Very good, guys. So now this is also finished. Now let's talk about the CANT, or you can say super elevation. Okay. Now understand. Suppose if we have a curve on the track. We know this at this time what is going to happen. You must have followed this as well. Let's take example of highway only first. So we have this curve on the highway. Suppose if the car is like this and we are moving in this direction. So when the car turns in the right direction, when we turn the car in the right direction, our body and the people who are sitting in my car, their body tend to go in the outward direction. I'm turning right, bodies are going in the left direction. Why? The reason being, quickly. The reason being, let me know guys, I'm listening. Reason being centrifugal force. Okay. Krishna, this will come in just few minutes. Okay, just be patient, little bit. Okay, obviously it will come, don't worry. Right, that is because of the centrifugal force, right, in this direction. Same thing happened with the train also. But in your car case, in your vehicle case, what we used to do is we used to see that okay. So here we used to show the centrifugal force, and it was being compensated by the friction also. Right, here we are not going to consider the friction. First of all, friction is neglected here. Guys, this is very important concept, so please do not miss this one. This is very important concept, don't miss this concept, right? So here the friction is neglected. First of all, understand this, right? So the basic formula of getting the super elevation, guys, is nothing but it is equals to GV square upon 127 R. What is the formula, guys? And what is the capital G here? First of all, tell me the track gauge or the dynamic gauge. Let's see who will tell me the first answer. Everybody, full power. Let's see who will give me the first answer. This will be GV square upon 127 R. And you know this, if you are my old student, that whenever I'll be writing V like this, it means I want to tell you that it is in kilometer per hour. And whenever I write the V like this, it means the velocity is in meter per second, right? Very good. So tell me guys, what is this capital G here? The capital G is nothing but it is the dynamic gauge. Quickly tell me guys, do you want to see a magic? Everyone, how many of you want to see magic? Let's take only 10-second break. How many of you want to see magic? Everybody, those who want to see the magic, just send me a heart sign in the comment box. I will show you how to do magic. Come on. Yes, this is a dynamic gauge, but first of all, heart sign. Come on. Let's see. The magic is going to come. Quickly, everybody. If you want to see magic, just send me a heart sign in the comment box with full power. Come on. Yes, nahi. No, yes. Only heart sign. Only. The more heart sign I will get, the more energy I will get for do the. Very good. Okay. We are getting lots of hearts. So I'm getting lots of energy for doing my magic. So my magic is this.
Hey, my champions. I welcome you all. My friends, you all are enjoying the marathon session of railway. And we are getting a huge response of this session. My friends are very good. And my friends, I must say that this session of Railway Airport, since sir, we are traveling and sir is saying that only 4 questions have been asked in railway, right?
Yes, sir.
And that too are from topic geometric design. So sir is covering that complete topic, and my friends, I must say that if you have watched this complete session, my friends, then it is not possible that you are leaving any question in gate, or not only gate, other competition exam, because most important thing to nichod hai na, the nichod is here. So good afternoon everybody, welcome, and my friends, Joshit sir and I again coming at 6 PM today on Great Upsell Champions YouTube channel with a surprise for you. 6 PM today, Great Upsell Champions YouTube channel. Please enjoy this session. Like and share this with your friends so that many people can enjoy this wonderful session of railway. And my friends, there's a last time of gate is coming, my friends. And this railway airport is not having a huge syllabus. This you all know. And you all are leaving some, I cannot say all, but most of you are leaving this. So why to leave? Just enjoy this marathon session and get all the questions. because my friend, most probable topics, in fact, I must say that if you see this session, 100% questions are going to cover from this session only. Sir is continuously working from last 1 week on this session, that what are the topics, not only in GATE but other company exam also. Yes, GATE is our focus, definitely, but sir is taking so many other papers also and seeing that what the most questions have been asked from which topic, and sir is taking that only. So huge effort sir has taken. So please, everybody, every command to just like and share and enjoy this session. Again, we will be meeting you at 6 p.m.
At
Okay.
6 p.m.
Okay, enjoy,
Thank you
sir.
so much,
Thank
sir.
you. Thank you. Thank you.
So guys, this was the magic. I hope you all have loved the magic. So now let's get back to the
business, right? So we were here. So I was telling you, this is the basic formula of getting the value of super elevation, that is GV square upon 127R. Now I will be telling you about different super elevation, right? Or here I'll be calling it CANT. Can I call it super elevation? Is it any crime? No, it is not any crime. You can call it CANT also. It is perfectly fine, right? You can call it CANT also. So guys, here there are different type of CANT. The equilibrium CANT is there. Okay, there is CANT deficiency. The CANT access is also there. The actual CANT is also there. The theoretical CANT is also there, right? There are lots and lots of CANT. So let me tell you guys one by one about all these things. Okay guys, so when suppose I have a train which is moving with velocity 100 kmph. There is a train which is moving with 100 kmph. Just imagine this, right? And I am going to design the super elevation for this 100 kmph, right? And as soon as I will design this super elevation for 100 kmph, you know what is going to happen? You know what is going to happen? Both the rails, the inner rail and the outer rail, are going to have the same. They are going to get the same stress on both the rails. Basically, the passenger is going to feel so much comfort, because the centrifugal force is going to be deducted, is going to be compensated with the help of the component. Whose component? Weight component, yaar, the weight component. All right. So guys, at that time we will get one equilibrium condition. Basically, what is equilibrium condition? Both the rails are having the same stress. That condition is known as the equilibrium condition, and the CANT at that time is known as the equilibrium CANT. Anybody have doubt in equilibrium CANT? Quickly just send me a doubt in the doubt section. But if it is clear, you have got the feel, please let me know that you have got the feel. Everybody quickly tell me guys. Yes, negative super elevation will be covered, don't worry. First of all, please tell me guys, equilibrium super elevation is clear? Equilibrium super elevation is clear? Anybody have doubt in this? Please ask. Okay, cool. Perfect. Okay guys, okay. Now understand guys, understand. Whatever CANT you have provided from here for this particular speed. Imagine there is another train coming whose velocity is 150 kmph, right? I have designed this particular section for 100 kmph. Right, but there is another train coming with the velocity 150 kmph. It is very obvious that it will require more super elevation, but the super elevation is provided is for this velocity. Then guys, what is going to happen? This particular 150 kmph train is going to feel a deficiency of the CANT. This particular 150 km/h of the train is going to feel a deficiency of a CANT, because for this particular train, 150 kmph wala train, we should have more CANT. We have provided this one, 400 kmph. Alright, so that is known as CANT deficiency. That is known as CANT deficiency. Now imagine that there is a train which is moving at 60 kmph. Imagine the train is moving at 60 kmph. Now what is going to happen with this? It is going to experience that, oh my god, the train is tilted. The train is tilted. The train is moving with very slow velocity. I have designed the super elevation for this velocity. Train is moving with this velocity. The train is going to feel a discomfort The passengers are going to feel a discomfort, and there is a high chance of derailment. There is a high chance the train may topple in the inner side. All right, guys, and obviously, this train driver will say, "Zyada ho gaya yaar. CANT to zyada ho gaya." Basically, we have provided the CANT in axis, so this is known as your axis CANT. This is known as your axis CANT. So we have discussed the equilibrium CANT. Right, whatever CANT you are providing practically on the field, that is your actual CANT. Okay, if the train require more CANT than the provided one, then that difference, the required and the provided, the difference is your CANT deficiency. If the required one is lesser, the provided one is higher, then the provided minus the required is your CANT axis. So these are 4 type of CANT. Anybody have any doubt in any of the CANT, 1 rupee doubt, 2 rupee doubt, or 1 crore doubt, please ask. Full power. Quickly. If you are enjoying the session, just quickly send me a heart sign, and also just hit the like button and share the video with any friend who is needing this particular session of railway and airport. Come on. Practice. I will do the practice for you. Don't worry. I am going to tell you how to design the super elevation. How to decide the speed. Speed we decide on the basis of the railway formula. Now the Indian Railway have provided their own formula. Earlier we were using the Martin's formula. No Martin's formula. No more Martin's formula. नहीं सुनेंगे अंग्रेजों की. बनाएंगे अपना formula. Right? So we have different formula now. Don't worry about that. With the help of question, we will see that. So actual CANT already told you. Now there are some limit also of the CANT, everybody. So there are some limits also for the CANT. So guys, basically in general case for broad gauge, what is the limit of your actual CANT? Anybody can tell me please. What is the limit? What is the limit above which I cannot provide the actual CANT? What is that value? Everybody in the comment box with full power. Come on. Okay, very good to see. Lots of hearts are coming. Thank you so much everyone. Is equilibrium CANT is the actual CANT? Yes sir. The CANT which you will provide on the site, on the field originally, that is your actual CANT. Okay, Mikala, good afternoon. You are late by the way, but okay, what we can say, right? Okay, so guys, under normal condition it is 165 mm. Under normal condition for broad gauge it is 165 mm actual CANT. All right, and if you have some permission from the chief engineer, then you can provide it up to 185 also, but that is also in the special case. Guys, 75 mm is the limit, is the limit for your CANT deficiency. It is not the limit of your actual CANT. Okay, come here. So now the CANT deficiency. All right, now guys, understand, if the velocity is somewhere around is less than 100 kmph, simple, please remember, for broad gauge guys, we have to provide it as 75 mm. How to use all these values? I have 2 questions, and in 2 questions you will get to know each and everything, and if the question will come in the examination from this concept, you will be able to make it, because I will tell you according to new provision. I'm not going to tell you the answer as per the old provision. The question will come from the new provision, so don't worry. Okay, so broad gauge is 75 mm here. For broad gauge it is 75 mm, but in exceptional case, if you have the permission of chief engineer, if the velocity is more than 100 kmph, then it is 100 mm also. All right, and the limit of CANT axis for broad gauge is again 75 mm. Please remember. Okay, please remember. इस बार रेलवे और एयरपोर्ट यूपीएससी में भर के आया था, सोल्यूशन करा दो सर. ठीक है, डन सर. वेट, आई विल प्लान अ सेशन जिसमें वी आर गोइंग टू डिस्कस ऑल द रेलवे एंड ऑल दीज क्वेश्चंस. नाउ फर्स्ट लेट्स डिस्कस द क्वेश्चन. This question, in this question, okay, first of all, please tell me this, please let me tell you guys that this type of question have never been asked in your gate examination, because it is as per the new provision. Okay, if this time the question will come like this only, right? And there's a high chance the exact question may come with different value. Okay, so now let me first read the question, let me explain you the question, and then we will work on the solution as well. Everybody ready? Everybody ready? In this I will also show you the procedure, that how to do this question. Okay, the complete procedure we will see. Understand guys? See here, calculate the super elevation and the maximum permissible speed, it is also known as MPS, for 2-degree broad gauge transition curve on a high speed route with the maximum sanctioned speed is 110 kmph. The maximum sanctioned speed is 110 kmph. The speed for calculating the equilibrium super elevation as decided by the chief engineer is 80 kmph. And the booked speed of goods train is 50 kmph. We are going to solve this question and you will not get any doubt in this particular question, trust me. Then I will tell you one more question, different values will be there, and there is something else also happen in that question. But first let's solve this question. Okay, first of all everybody tell me the radius. First of all do that, okay, which you can do. I will make you do yourself. Okay, so please tell me the radius. First of all everybody, first of all tell me the radius. The first step always it should be get the value of radius. Okay, should I solve here only? इधर ही कर लेते हैं. So the radius will be, guys, how much? Radius will be how much? It will be 1750 by D. Everyone please let me know if my handwriting is understandable, and also please tell me if I'm not writing very small. I'm using the smart board 10 months, so maybe there is slight changes I can do for you. But first you tell me, guys, if the handwriting is not understandable, or if I'm writing too small or too large. Too large is okay, but if it is written too small, please let me know, right? I don't want to waste your time. So it is 1750 over 2. Very simple. It will be how much? 875. Brilliant. 875 meter. 875 meter. This is the radius. Okay. Now get me the super elevation for equilibrium speed, everybody. Get me the super elevation for equilibrium speed, everybody. Get me that super elevation for equilibrium speed, everybody. Full power के साथ. Everybody, if you will solve, you will get the practice. If I will solve, I will have the practice, and I don't need to get the practice, okay guys, because you have to give the examination. Come on, tell me. The formula will be GV square upon 127R. G will be 1750. In mm I'm writing, right? Velocity will be how much? 80. So 80 square divided by 127 into how much is the radius? 875. So this should be how much? Everybody answer. Everybody answer here quickly. 1720 or 1750, sir. I've already explained this. Dynamic gauge. That is dynamic gauge 1750. And 1750 is when we are considering 100 feet chord. That is 30.5 meter. That is 30.5 meter. So yes, very good. And no answer I have got till now. Why? Why is that happening? It should be 100.8 mm. Okay guys, 100.8 mm. Now get me the super elevation for maximum speed, everyone. Get me the super elevation for maximum speed. That is 110. This is the third step. The third step is super elevation for maximum speed. How much is that? 1750 into 110 square upon 127 into 875, right? Is it 875? Yes, it is. How much is this is coming? How much is that coming? How much is that coming? 190.6 mm. 190.6 mm. Now, first of all, please check if my CANT deficiency is under limit. Please check if my CANT deficiency is under limit. Very good. Aman, Karam, Divya, Nivedita, Miss Rasu. Very good. Julie, Bhagat, Abhay, Sagar. Good. Please tell me if our CANT deficiency is under limit. So the CANT deficiency here will be how much? Fourth point is the CANT deficiency or CD should be how much? It is 190.6 minus how much was that? 100.8 minus 100.8. So everybody quickly respond and let me know, guys, how much is this value? CANT deficiency. So CANT deficiency is coming as 89.8. 89.8. So I have already told you guys, exceptional case such as the speed is 110, that is more than 100 kmph. Also it is high speed route, so it is an exceptional case. The chief engineer says you have to take 100 mm as a limit of CANT deficiency. Can I say it is under the limit? Can I say it is under the limit? Yes, it is under the limit. Yes, it is under the limit. So perfect. Till this point, everything is going fine. Till this point, everything is going fine, right? Now get me the super elevation for booked speed. Get me the super elevation for booked speed. Everyone, for booked speed, it will be 1750 into how much is the booked speed, everyone? It is 50 km. This is the minimum limit basically, right? This is the minimum velocity. This is 50 kmph, right? So 50 ka square divided by 127 into 875. Everybody quickly get me the answer for this. Quickly get me the answer for this. Yes, it is under the limit. 100 mm was the limit for your high speed, or you can say more than 100 kmph velocity, right? So this is how much? This is 39.4 mm. I have the answer already with me. 39.4 mm. Now guys, check for CANT axis. Now check for CANT axis and tell me if CANT axis is under limit or not. If CANT axis is under limit or not. So CANT axis will be how much? CANT axis will be how much? We have provided how much? 100.8 is the actual CANT minus 39.4, and this is coming as 61.4. So yes, it is also under limit. It is also under limit. It is also under limit, right? Abhay 100. Those I can understand that there may be some doubts, because earlier the values were different. Earlier the things were different. Now the everything have been revised. That is the reason why I am carrying out this particular marathon, because things have changed. I really don't want you to get into all those confusions. This is once and for all discussion, right? So guys, here the CANT axis is 61.4 mm. That is under the limit. Everybody, this is fine. Okay, everything is fine. Everything is under limit. Very good. Now let's work on the maximum speed. The maximum safe speed. Let's try to find out the maximum safe speed. Now, the Indian Railway formula for that is, the Indian Railway formula for broad gauge is this. V is equal. This is nothing but it is your that formula only, right? CANT deficiency limit. Whenever there is more than 100 kmph velocity, your CANT deficiency limit should be 100 mm. Below that, it is 75 mm. Right now, I was getting somewhere around 89.8, I guess. It was less than 100 mm because I have the velocity as 110. Please do not get confused here, right? So it will be, guys, 0.27 under root the actual CANT plus the CANT deficiency into the radius. This is the formula for your maximum speed. As per this, can you quickly let me know what should be the answer? Please tell me. Please tell me. So please repeat axis and CANT efficiency. Okay, axis CANT is the CANT. The actual CANT, whatever the CANT you have provided, that is actual CANT, right? and the CANT that you are finding for the minimum speed, right? Just subtract those and you will get the CANT axis. Okay, limits are, let me put down the limits here. The CANT deficiency limit are 75 mm in your normal condition. That is when your velocity, the maximum velocity is less than, the sanctioned speed is less than 100 kmph. Use 75 mm as the limit. But if it is more than 100 kmph, the sanctioned speed, then the CANT deficiency limit is 100 mm. CANT axis is always 75 mm for your broad gauge. These values are for broad gauge. Okay, this is what you were asking. Clear? Perfect. Now guys, let me know the velocity here. Everybody, how much we are getting? Actual CANT is 100.8. The CANT efficiency is 89.8. The radius is 875. So now you tell me guys, what should be the value of this velocity? Can we hit 100 likes everyone for my energy at least? Please. Just we'll try. Okay, we'll try if we can reach out to that. So we have 0. How much? 27 into under root. The actual CANT was how much? 100.8 plus CANT efficiency was 89.8. Yes, it was that. And the radius is how much? 875. So this is coming as 110.1. Correct or not? Everybody answer. 110.1. Correct or not? You have to put actual CANT as 100.8. You have to put CANT efficiency as 89.8. Why? And radius you have to put 875 here. Why? Answer is this. This is the CANT, right? This is the CANT deficiency, right? And this is the radius. That's why. If the question was why, then that's why. Okay guys, clear? Brilliant. Now I have got this velocity. Now the thing is, the maximum permissible speed is the least. The maximum permissible speed is the least of, now understand, least of what? Okay, why not, why CD not 100? Dost, please tell me what is the CANT deficiency in this question. According to the values, what is the CANT deficiency? Look here. CANT deficiency is 89.8 for my question, and it was under the limit. That is why I did not change it. I kept it as it was coming because it was under the limit. The limit I have already shown you. 75 when you have less than 100 kmph, 100 if you have more than 100 kmph. The velocity sanctioned was 110. That is why. Okay, why sir CD is not max CD possible? Those the thing is, if the CANT efficiency will be more, then the outer rail will be getting more load in comparison to inner load. So what is going to happen? The outer rail is going to experience more load for more period of time, and that is going to fail the material of that outer rail. I have to change that rail very often in comparison to the inner rail, and that is the reason why we cannot exceed the limited value, that is 100 mm or 75 mm of CANT deficiency. Clear? अब ये करके दिखाओ, रैप हो गया पूरा. चलो भाई साहब, यहां तक सेट है. नाउ अंडरस्टैंड द मैक्सिमम परमिसिबल स्पीड विल बी either maximum sanctioned speed. I will mention here maximum sanctioned speed. What is the maximum sanctioned speed, everyone, for this question? What is the maximum sanctioned speed? Everybody answer. Or speed from railway board formula. Speed from railway board formula. This was 110 kmph and this was 110.1 kmph. right? Correct? Tell me values. Correct. So guys, please see here, we have to choose least of these two. So the least of these two is this. So our maximum permissible speed will be 110 kmph, and the super elevation which I am going to provide is 100.8 mm, because everything was under the limit, because we were getting everything in the limit. That is why I am saying my value is perfectly correct. CANT access is under the limit, CANT deficiency is under the limit, everything is under the limit. I am very happy, you are very happy. What else we require? And it is also coming under the limit of super elevation. What was the limit of super elevation? Actual CANT wala, that was 165 mm. It is under that limit. Now everybody tell me if you are getting it with full power. Just send me a heart sign in the comment box, hit the like button. Let's reach to the 100 likes and share the video. If you are new, just subscribe the channel as well. And then we will solve another question. Now the question which I am going to solve, there will be limits, there will be the values which are going to exceed the limit. So now we should not use Martin's formula. Yes, we are not using, because Indian Railway in the new provision has said that now we are going to use the Indian Railway formula for the velocity, and Indian Railway formula is this for broad gauge. This one. This is nothing but this is your CANT formula only. Clear? Now the question which I am going to solve is the value which you will get, they are not under the limit. They are not under the limit, right? Because this type of question is very important when the things are not under the limit. How to deal with that type of questions, that I'm going to tell you here, right? See all the love that I'm getting. Thank you so much, everybody. Thank you so much. I hope this session is making sense to you, and I hope you are getting something new from this session. Let's see the next question. Why I'm not focusing on other things? You must have seen this, that I am taking a lot of time in explaining you these three concepts, the CANT concept, because it is important. If the question will come, 100% chances are there. The question may come from here. 100%, or you can say 99.9999%, because I can't also say that 100%, right? Let's see the next question. The question, as soon as you will read the question, tell me, are you seeing any difference here? Any difference? Just don't look at the values. Obviously the values are different, but in the language anything is different. This is just to show you that there is no difference in the question, and that time also we can get something, we can get some values which are not under the limit. How to deal with that question? This is how we are going to do it. Just please look at this. Calculate the super elevation, maximum permissible speed, and the transition length. I will tell you how to find out transition length also, don't worry. Okay, sir, CANT axis का यूज था इसमें. CANT axis किया ना, अगर लिमिट में नहीं होता CANT axis वाला तो अपने को चेंज करना पड़ता. अगर CANT axis लिमिट में नहीं होता, यहाँ पे देखो CANT axis लिमिट में था. CANT axis होता है 75 mm. ठीक है, बुक्ड स्पीड इसीलिए दी थी. बुक्ड स्पीड की मदद, यू कैन गेट द वैल्यू ऑफ, विद द हेल्प ऑफ बुक्ड स्पीड यू विल गेट द वैल्यू ऑफ सुपर एलिवेशन फॉर बुक्ड स्पीड, एंड दैट विल गिव यू CANT axis, and from that CANT axis you will compare the limit. Limit was 75 mm. It is under the limit of CANT axis. That is why G value is 1750. Again and again I'm telling you, those who have joined late, let me tell you guys, I have already discussed this thing, that we use dynamic gauge, not the track gauge. The gauge which you are telling me 1676, that is the track gauge, but we use dynamic gauge which is from center to center. This is the slight drawback of joining late, because I have discussed these things already in the same session, right? So please see here, 3-degree curve on a highway, high speed broad gauge with a maximum sanctioned speed. This, guys, are you seeing any difference? Even the values are also same, only one thing is different, that is the degree. Yes or no? Everybody have read the question? Abhay, doubt is clear? Amani, doubt is clear? Everybody tell me, are you seeing any difference here other than the degree curve? I will use Abhay, agar if it is not in the limit, then we are solving this question. You will see if they are not in limit, then what is going to happen. Are you not listening what I am saying? Listen now what I am saying. I have just said I have just said. Okay, everybody, full power. Anyone? Cool? Okay, come back. Now guys, understand this. Radius please. Everybody, radius please. Everybody, radius please. The first step is the radius. The first step is the radius. Everybody, full power radius please. In the comment box. Full power. The first thing is the radius. Always remember, the first step is radius, and then we will move to the equilibrium concept, and then we will move to the CANT efficiency, and then we'll move to the CANT axis. Everything should be in limit. So the radius should be how much? 1750 divided by how much is the degree? 3 degree. So the radius will be, the radius of curve will be 583.3 meter. Correct? Yes, it is correct. I know I have the solution already. Now the second thing is, get me the super elevation. Get me the super elevation for what? Get me the super elevation for the equilibrium speed, everyone. For the equilibrium speed, everyone. Super elevation for equilibrium speed. Everybody will give me the answer. Give me the answer with full power. It will be 1750 into velocity is given as 80. 80 square 127. R is 583.3. बिना देखे लिख दिया. अब बताओ आंसर फुल पावर के साथ. 151.2. Very good. Who gave the answer? Karam. Very good. Very good. 151.2 mm. Are we getting the same answer? Yes, we are also getting the same answer. Now get me the value of super elevation for sanctioned speed by chief engineer. Super elevation for maximum speed. Everybody will give me in the comment box. Now, so it is 1750. Velocity is how much? 110 square divided by 127 into 583.3. So from here we will get the value of super elevation as, let me see, it is 285.5. correct? Very good, Nivedita. 285.8. 285 point, how much you are getting? 285.8. correct. I am getting it as 285.5 only. Cool. Now what is the CANT efficiency, everyone? What is the CANT efficiency, everyone? Karam, don't jump on the CANT axis because there is some slight problem here. CANT efficiency, everybody with full power, 151 is the actual CANT, and it is my CANT corresponding to maximum speed, 285.5. 285.5. How much is the value here? The CANT efficiency, everybody, that I am going to get is 285.5. 285.5 minus 151.2. And how much is the value? Answer please. There is no calculator. Okay. So guys, if you are not aware of this thing, let me tell you one more time. Today 6 p.m. me and Abhinav sir are joining you exactly at 6 p.m. on Grid Up Civil Champion YouTube channel with a great surprise for you all. Don't miss the session. The CANT efficiency from here will be 134.6. Is this in the limit, guys? Is the value is under the limit? Now we will have fun, guys, here. How? It is not under the limit, and I cannot provide CANT efficiency more than the limited value. So I have the CANT efficiency as 100 mm. So provide CD as 100 mm. Provide CANT efficiency as 100 mm. So if I will provide 100 mm, then what will be the value of actual CANT, everyone? If I want my CANT efficiency as 100 mm, then what should be the value of CANT? What should be the value of actual CANT, everybody? Please tell me. Please tell me. If I want 100 mm of CANT deficiency, then what should be the value of my actual CANT, everybody? The actual CANT will be how much? It will be 285.8. It is 8 only. 285.8 minus 100. And how much is this? 185.8. 185.8 mm is the actual CANT. So when I will provide 185.8 mm, I can get 100 mm of CANT deficiency. Now CANT deficiency is under limit. Are you happy? Yes, you should be, because I am. Clear, everybody? Anybody have doubt till this point? Ask. If I will provide 185.5 mm of actual CANT, then I can have 100 mm of CANT deficiency, because after getting 100 mm of deficiency, I can accommodate the train which is moving with sanctioned speed also. Correct? Divya, very good. Nivedita, very good. Answer please, everybody. Is it correct? 185.8. 185.8. Everybody correct? Everybody correct? Quickly respond. Very good, Aman. Very good, Abhay. Set hai. Full power. Brilliant, brilliant. Now see here, guys. But can I provide this value of actual CANT? Can I provide this value of actual CANT, everybody? Why not add 100 in equilibrium super elevation? If you will provide 100 in equilibrium super elevation, it will become 251.2 mm. Correct, Amit? It will become 251.2. Correct, Amit? Right? But for sanctioned speed, I want CANT as 285. The CANT deficiency will be more than, the CANT deficiency is still not being satisfied. That is why. Okay, I have to take care that CANT deficiency should remain 100 mm, right? And this is the value which I required for my maximum speed super elevation. But the problem is I cannot provide this because it is 185. It should be 165 for the limit. So I will adopt the actual CANT as 165 mm. अब ना कोई बहस होगी, ना कोई बात होगी, ना कोई दलील होगी, सिर्फ और सिर्फ होगा फैसला, because this is your actual CANT value 165 mm under the criteria of Indian Railway, which they have provided in a chart, right? That this is the limit. So we have to provide 165 mm of actual CANT. 165 mm of actual CANT. Cool. Cool. Now tell me what will be the super elevation? What will be the super elevation for booked speed? Let's check for CANT axis. For booked speed, everyone, let me know. 1750. Velocity was how much? I think 50 kmph. Yep. 50 ka square. 127 into 583.3. 583.3. Everybody get me the answer. Super elevation. Everybody answer. Full power. How much? It should be 59 mm. It should be 59 mm. Now check for CANT axis. This is actual CANT. And this is your CANT for this value. Now check for actual CANT. The actual CANT will be, the axis CANT will be 165 minus 59. How much? How much value we are getting from here? This will be, guys, 106 mm. This will be 106 mm. Again, it is not coming under the limit. The limit is 75 mm for CANT axis. So now tell me what should be the actual CANT. Everybody in the comment box with full power with a heart sign. Everyone, come on. Tell me. And also, let's reach out to 100 likes for this particular video and amazing session on your railway and airport engineering. Come on, guys, full power. And do not forget about the 6 p.m. session that we are going to have on Grade Up Civil Champion YouTube channel, because me and Abhinav sir will be joining you exactly at 6 p.m. So we are 52 people right now and going great. Good. Very good. 106 is the right answer. Come on, which is exceeding your CANT access limit. So what should be the value? Come on. Yes, the PDF will be uploaded to your Telegram group. If you have not joined the Telegram group, kindly please join the Telegram group. Everybody, full power. So actually the value of your CANT will be, that to actual CANT will be how much? It will be 75 plus 59. And how much is that value? 134. Very good, Abhay. This is correct answer. 134 mm is the answer. Beta meter nahi hoga. Mm. Correct. Full power. Brilliant. Now tell me, guys, if you have any doubt, 1 rupee doubt, 2 rupee doubt, 1 crore doubt, let me know what is your doubt. Come on, everybody, full power response. Just look at here, take the screenshot if you want. Chaliye, everybody. So this is all about your super elevation, all the type of question which I am just solved in front of you. This is the possible chance, guys. Initially, we have solved this question in which everything was coming under the limit. Right, the CANT I was getting as deficiency as 89.8, and it was high speed route. Also 110 kmph was the sanctioned speed. That is why the CANT deficiency limit was 100 mm, right? But here I was getting 89 point. Bach gaye, no problem. Similarly, the CANT access I was getting as 61.4. Bach gaye, because 75 mm was the limit. Come here. Then we have seen this one, but here the CANT deficiency bahut zyada, 134, sir. 134, right? 134. Also, the CANT access bahut zyada, 106, right? So eventually, the actual CANT that I am getting is 134. It is satisfying the CANT deficiency. It is satisfying the CANT access. It is satisfying everything. Now tell me, guys. Yes, last May we are going to provide 134 mm. Also, it is under the limit of actual CANT as well, right? So now there is no problem. कोई संदेह नहीं है, कोई शक नहीं है, कोई दिक्कत नहीं है, सिर्फ और सिर्फ है तो फैसला. This is your actual CANT. Everybody doubt, please ask. इससे सब लिमिट में आ गया. Exactly, अबे. This is what I was trying to tell you. Good afternoon, Varsha. Welcome to the session. All right, guys. Sanctioned speed book, speed must be changed, right? Don't worry, guys, don't worry. It will be taken care of. Now tell me the safe speed, everybody. Full power ke saath, with the help of Indian Railway formula, I want the answer. With the help of Indian Railway formula, I want the answer. Tell me what is the safe speed with the help of Indian Railway formula. Safe speed, everybody, with the help of Indian Railway formula. Indian Railway Board, the provided. Everybody, quickly. 0.27, this is the formula, guys. 0.27 under root CA plus CD into R. Put the value of CA as 136. Put the value of CD as, what will be the value of CD? Everybody, half century is there. 52 people are watching and nobody is answering. Why not? Tell me quickly, full power ke saath. That would be 100 mm, guys, because I have adopted 100 mm as the CANT deficiency. So here the safe speed should be how much? 99.75. Amazing. 99.75 kmph should be the safe speed. Now you tell me which value I have to provide. Quickly let me know the answer. Come on, guys, quickly let me know the answer. 99.75 kmph is the value. Now quickly tell me, everybody, what should be the speed? This is somewhere around 100 only. Yaar, this is only 100. So this is 100 kmph. The sanctioned speed was 110. So I have to provide 100 kmph as the velocity. 100 kmph as the velocity. Any doubt? Any problem? Please tell me, everybody. Full power के साथ. If you have a problem, but if things are clear, then let me know in the comment box with full power, everyone. Full power. And let me tell you guys, the complete civil team is sitting in just front of me. Abhinav sir is here, Shubham sir is sitting here, and they are making fun of me. So please, answer चाहिए मेरे को. That is also correct answer. Okay, इज्जत का सवाल है भाई. So basically they are trying to make me laugh, and that is the whole thing. But अपन पिघलेंगे नहीं. Answer everyone, full power के साथ. Answer everybody. Answer. Right? So guys, length of transition curve is the next concept. Let me tell you here only, very small concept. First of all, transition curve is provided by the same thing why we used to provide in your highway engineering. Same thing why we used to provide in highway engineering. That is the reason, right? So transition curve, why? Because my particular, let me see. This is the transition curve, right? So guys, we have different type of curve. We have cubic parabola, we have the spiral curve, we have the Bernoulli's lemniscate curve. We are going to provide which one, everyone? Everyone, sir, हमें CANT efficiency, actual CANT 134. Sir, the whole process is designed in such a manner that you don't have to go back to the first point again, right? Just do this. Initially get the value with the help of equilibrium speed, get the value with the help of maximum speed, get the CANT efficiency, make it under the limit, check the actual CANT is coming under the limit. If it is not, keep it under the limit, and you are going to get the answer. So don't worry. Okay, so don't worry. ऋषभ दोस्त मुझे माफ कर देना, बट इस वाले पर्टिकुलर यूट्यूब चैनल पे हम लोग इंग्लिश में ही पढ़ाते हैं, लेकिन जो आपका ग्रेड अप सिविल चैंपियन है ना दोस्त, उस पे हम लोग हिंदी में पढ़ाते हैं. तो 6 बजे उस पे मैं और अभिनव सर आ रहे हैं आज, और आपको जानकर खुशी होगी ऋषभ, हम लोग ला रहे हैं एक बेहतरीन सरप्राइज आपके लिए. ठीक है, 6 बजे मैं और अभिनव सर एक साथ होंगे यहीं पे आपके सामने, राइट? ग्रेड अप सिविल चैंपियन यूट्यूब चैनल. बट इस वाले चैनल पे दोस्त मजबूरी है, इंग्लिश में ही पढ़ाना पड़ता है, राइट? उस पे केवल हिंदी, उस पे कोई इंग्लिश नहीं बोलेगा. दैट इज माई प्रॉमिस, राइट? सो एवरीबॉडी क्विकली टेल मी which curve I am going to provide in case of your transition curve in your railway engineering. So here we are going to provide the cubic parabola, and guys, let me tell you here, let me draw the curve also for you. So here we have a curve like this. Like this is the curve, everyone, right? So I am going to provide the cubic parabola. Very good. Ravi Teja, Akash, and Divya. Cubic parabola is the right answer. So from here, I'll be having a track like this. Okay, and then this is my transition curve. And here I'll be having the curve. This is basically the circular curve, right? The horizontal curve, everyone, correct? Okay, so now there are few things that you need to understand, guys. First of all, if you make a tangent from here, let me take another color. If you make a tangent from here, this angle is represented by phi, and this is known as the spiral angle. It is known as the spiral angle. And this angle here is represented by alpha, and this is known as your deflection angle. Alpha, it is known as your deflection angle. Instead of 3 hours, we'll be taking, I think, 2 hours only. So don't worry. Okay, in the previous problem, will the book speed? No. I have got all the speeds. According to speed, I have designed the super elevation. So if I have to change the velocity, then why would I have changed the super elevation? I would have changed the velocity. No, Ravi Teja, is it correct? Is it making any sense to you? Please tell me. If I have to change the velocity, then why I will bring the super elevation into the limit. I will simply change the velocity to bring the velocity so that I can get that super elevation. Okay. Okay. What is the standard transition curve in case of railway and highway and also normally provided curve? In your here you provide a spiral curve. Here you provide cubic parabola. Here you provide cubic parabola. There you provide spiral curve in highway engineering. All right, this is the basic difference between these two, right? Here I'll be providing cubic parabola. This blue color is showing you the cubic parabola, and the equation is this: x cube by. This is the equation for your cubic parabola. In case if you want to know, then this is the equation, right? So this is your spiral angle and this is your deflection angle. There is only one thing that you need to understand about this, that the phi value is, guys, let me tell you here only. Should I write here? Is it visible? So here the phi value, the spiral value is nothing but, the spiral angle value is nothing but it is tan inverse. It is tan inverse bracket के अंदर we are going to keep x square by 2l by 2rl. This is the value of your phi. Question will not come from here. If it will come, you should know it. That is it. Okay, that is it. This is the only thing which you need to understand. भाई कौन कॉल कर रहा है सर? मत कॉल कीजिए प्लीज. ठीक है, ठीक है सर, ठीक है सर, ठीक है सर. अल्फा अल्फा बराबर tan inverse x square by 6rl. Finish concept. The question that will come from this concept, the question that will come from this concept is the length of transition curve. How to get the length of the transition curve? Let me tell you guys crisp and clear directly that how to get the length. So basically there are three criterias, right? So two of them are basically designing and the third one is your checking. Basically you are checking whatever you have provided, that is correct or not. Okay, right? Okay. How can you please elaborate your question, please? How you wanted to ask? How you are asking? quickly please, we don't have time, that much time. In case you are asking how that phi is coming, then firstly let me tell you guys, I'm not here to tell you each and everything, right? Because we don't have time. How questions? Sir, let me explain first, then ask. No, I have already shown you some questions, so just keep the trust on me. You are coming to my session, just trust me. I am going to solve the question also along with the concept, right? First let me tell you how to get the value of your length, transition length. Okay guys, so first is the transition length. Very simple guys, you already know few of these things, right? So first of all, the length can be determined as L is equals to 0.008 into actual CANT into velocity. Okay guys, and another one is 0.008 into CANT efficiency into velocity, and the last one for checking criteria, it is 0.72 into E. 0.72 into E. 0.72 into E. All right. E is nothing, actual CANT only. Somewhere you write E, somewhere you write the CA only. Don't worry, I'll be writing this C only, don't worry, right? Now guys, this is the simple thing, and you have to take the maximum of these. Now quickly, let's get back to the question. This was the question. Can you quickly tell me the length of the transition curve for this question, everybody? Quickly, please tell me the length. There the value of CA, CD were in mm and the value of velocity was in kmph. Please do not make mistake. Please solve this one, everybody, for me. Yes, Abhay, very good. Please solve this for me. Everybody answer. Full power के साथ. Initially, my first words was that the syllabus is this much, the syllabus coming in examination is this much, and in this class I am teaching you this much, right? This should be already, like, you know, we should have this mutual understanding. So can we hit 100 likes, guys? How many likes are there? Can anyone tell me? Because the likes are hidden behind the camera, I cannot see how many likes are already there. Can you quickly please hit the like button and let me know how much are the likes right now? Also, please get me the value. Also, please get me the value. Also, please get me the value of transition length. Okay, let's solve this. Okay, so I will see quickly. The value of actual CANT here were 134 mm. CANT efficiency was 100 mm. Cool. So I'll be solving here only. So the first thing was 0.008 into actual CANT into velocity. So actual CANT was how much, guys? 135, I suppose, right? You have to take it, you know, multiple of 5 only, right? So actual CANT was 135, and this velocity was how much, guys? Velocity was how much, guys? It was 100. It was 100 only, 100 kmph. So from here the answer should be 108 meter. No problem. With the second criteria, 0.008 into CANT efficiency into velocity. This is 0.008. CANT efficiency was 100 into 100. How much is this value, everyone? This is 80 meter. And the last one, the last criteria is your 0.72 into actual CANT, and that is 0.72 into actual CANT is 135. From here, the third criteria will give me the answer as 97.2 meter. Everybody, please, in the comment box, let me know what should be the value of the transition curve. Are you going to take airport engineering in this session as well? Obviously, Tejas. See, I have written also. I'll be taking, don't worry. 92 likes, perfect. Thank you so much. Only 8 likes behind we are going. We'll get them. Come on, everyone. Is it correct? 108 meter. The correct answer is 108 meter. Right? Yes, right. Because this is the maximum, 108, 80 and 97.2. This is the correct answer, right? This is how you will get the value of transition length. Now there are gradient, guys, different type of gradients. Let me tell you guys, different type of gradients we have, right? So not very much important. First, let me tell you guys, there is this ruling gradient, the maximum gradient which we want to provide in practical conditions, right? The most favorable is your ruling gradient, right? In case we are not able to provide the ruling gradient, suppose we have hilly region and we cannot provide that particular you can say gradient, then we are going to provide momentum gradient, right? What will be the momentum gradient, everybody? So please also provide ESE syllabus coverage after GATE. Okay, Arvind, if you are enjoying, guys, let me please know if you are enjoying this session. If you are enjoying, then obviously I will bring ESE syllabus also. Everybody, full power say, please respond in the comment box if you are enjoying the session or not. It is just, you know, beneficial for me only to know the feedback. If you really want it, then I have to bring ESE syllabus also. Answer. Okay, I have just opened the chat here also so that I can have a clear picture. Bataiye sir, everybody, quickly. Right? So there is this momentum gradient, there is this pusher gradient, right? Not at all important right now for us, okay? Yes, Abhay. First two are your comfort criteria based, right? And third one is your safety. Basically, we are checking them, right? Right. Okay, the gradient which we provide in your station yard. Why we need gradient in station yard, everybody? First of all, the drainage condition. Whenever we are going to clean the engine or locomotive, you can say, at that time, at that time we have to drain off the water, and to drain off the water we are going to provide a gradient. We are going to provide the gradient, right? The gradient should be 1 in 400 to 1 in 1000. Why we have a range? One thing is gradient is this only, dost. Suppose this is your track and then you have this gradient. This is the gradient, that's it. This longitudinal slope is your gradient, that's it, simple as that. Okay, right? The question which may come here are, let me tell you guys. Okay, this is the radius, everyone. You can see the minimum radius as per the groups, different type of groups we have already taken. Please take the screenshot. This is the standard data. And then we are going to understand the grade compensation. Now grade compensation, exactly the same thing what we have discussed in highway engineering. So whenever we have a curve, we get this curve resistance, right? And whenever we have a gradient, we can feel that our vehicle is being pulled in backward direction by some power, and that is nothing but the gravitational pull, right? So if we have curve and gradient at the same place, we will have two type of losses. One will be your curve resistance and second will be your loss due to that gravitational pull. Now in that case, to minimize the losses, what I am going to do? I am going to compensate the gradient. I will reduce the gradient, and when I will reduce the gradient, I have to provide the grade compensation. So everybody, please note this down. It is very important that the grade compensation for broad gauge is 0.04% per degree of the curve. 0.04% per degree of the curve. Okay, or 70 by R, whichever is minimum. So maximum case, in the most of the cases, minimum value is this only, right? Now how to solve the question if the question will come from this particular concept? The question they will provide you is like this. Find the, basically they will tell you, find the steepest gradient. I will mention here, find the steepest gradient. I have the question here with me. Steepest gradient on a 2-degree curve, for a broad gauge line, for a BG line with a ruling gradient of 1 in 200. Everybody answer. First, please let me know what will be the value of grade compensation here. What will be the value of grade compensation here? Everybody, full power, let me know. The compensation for 2-degree curve will be how much? Compensation for 2-degree curve will be how much? Compensation for 2 degree will be how much? I have already told you 0.04% per degree. If I have 2 degree, then it will be 0.04% into 2, that is 0.08% is the grade compensation. Now what will be the compensated gradient? What will be the compensated gradient, everybody? The compensated gradient, everybody please tell me. So 1 in 200 means how much in percentage? 1 in 200 means how much percentage, everybody? 1 in 200 means how much percentage, everybody? Please respond. Did we hit the 100 likes, everyone? Can you please tell me? Because my energy is connected to likes. Nothing else I'm asking you. I'm not asking you pay me some money, then only I'll going to give you the quality content. I'm already giving you content, right? You just have to give me a like and a share and a subscribe button. How much time you will take to do this? Maximum 0.5 seconds or 1 second maybe, if you are on laptop. Answer please. Compensated gradient. the compensated gradient will be, guys, 1 in 200 is nothing but it is 0.5%, right? It is 0.5%. So 0.5 minus 0.08, this should be how much? This should be 0.42%, 0.42%, and this is nothing but it is how much? 1 in 238. This is the steepest gradient which I can provide. This is the answer. Clear hai? Anybody have doubt? Look here and tell me if you have a doubt. Look here and tell me if you have a doubt. Everybody, full power. Everybody with full power, tell me if you have a doubt. If it is clear, then also please let me know. Then also please let me know. Clear? 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 Perfect. Very good, everyone. Very good. Correct answer. Ab hai Divya. Correct answer. Very good. Perfect, 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 perfect. Chaliye, let's move to the another concept. Let's move to the another concept, and this concept is from your okay, let me tell you how much you have covered right now. So 4 marks I have already told you that time, right? 4 marks I have already told you, right, at that time. Okay, so let me calculate how many marks we have covered till now. How many marks we have covered till now? Clear? Okay. How 1, 2, 3? Arey sir, the way how we have got this 0.5 from 1 by 200, same thing. If you have got this 0.5 from 1 by 200, then why can't you get this from 0.42? How hard it is? Come on, guys. You have to just do few things by yourselves. Okay, don't worry. Things are easy. They are not tough. We are the ones who try to make them complicated. They are not, right? Okay, so the marks which we have covered till now is 4 marks were there. Now from super elevation, if the question will come, it will come for 2 marks, right? For 2 marks. Then we have seen if the transition curve will come, length of transition curve will come, +2 you can easily add. Till now we have covered 8 marks from your railway engineering, right? If any question will come from such topic which I have discussed, you will be able to solve them. So don't worry. You have not wasted your time. Okay? You have not wasted your time. Come on. Then the next question is, then the next concept is your widening of gauge on curve. Guys, it is very simple. This is the basic formula, sir. Right? This is the basic formula, sir. Okay? Okay? बहुत बढ़िया सर. मैं सोच कर आया था कि मैं 100 लाइक मैं ही क्लिक करूंगा. सही है सर, वक्त आ गया है. दिखा दे कमाल आप अपना. Okay guys, so extra widening also we provide on the curve, right? Okay, so understand how to solve this extra widening. So direct formula we have, that is 13 plus b plus l square. If you can't see it, please see 13 b plus l whole square. After this we are going to discuss the airport engineering, everybody, right? Here b is the wheelbase and l is this. L is this 0.02 h square plus dh raised to the power 1 by 2, where the small h is the depth of the flange, small h is the depth of the flange, and capital D is the dia of the wheel. Capital D is the dia of the wheel. So I don't think कि भैया इस question में anybody will get any doubt. Please solve. If you have a doubt, please ask me. First solve by yourself. If you have a doubt, then please ask me. Everybody, what they are saying is the wheelbase of a vehicle of a BG track is 6 meter. The diameter of the wheel is 1524 mm. The flanges project 32 mm below the top of the rail. Determine the extra widening of the gauge required. Curve is also provided. Everything is already provided. So first let's get the value of lap. First let's get the value of lap of flange. Everybody, what is the lap of flange? Basically the L value we have to find out.
Basically L value we have to find out. The formula was 0.02 under root h square plus dh. Everybody answer. Everybody answer. The h value is given as 3.2 centimeter. You have to put it in centimeter. .2 centimeter. Right, and here we have to put the value in centimeter for dia also. 152.4 into h value is how much? Again 3.2 centimeter. How much is this value? Can you please tell me, guys? How much is this value? Can you please solve it for me? Everybody. Quickly tell me, quickly. How much is this value? This is 0.446 meter. This is 0.446 meter. This is 0.446 meter. Yes. So the extra widening. So the extra width. will be 13b plus L whole square by R. Wheelbase is given as 6 meter. So 13, 6 plus 0.446 divided by the radius, and radius is given as how much? 168. You solve it and you get the answer as 32.1 mm. And this is your final answer, and this summarizes your railway engineering. And let's begin the airport engineering with full power. Everybody please tell me, did you enjoy each and every minute of railway engineering full power ke saath? Because you are going to enjoy railway engineering also. Now I will take only 20 minutes more of yours. 20 minutes more of yours to explain you everything about airport engineering as well. And guys, trust me, it is very interesting. If you have enjoyed the complete railway, send me a quick hearts in the comment box, and also please hit the like button if you have joined just now, and also subscribe the channel if you are new to the class, because we are going to conduct such session. Okay, there is one more announcement for you all who follow only Grade Up Gate, who understand only English, and you are only following Grade Up Gate channel. Me and Abhinav sir are beginning a new series. Me and Abhinav sir are beginning a new series on Grade Up Gate channel. On Grade Up Gate channel, in that series, we are going to take every subject. My 4 subjects, and Abhinav sir will take his 4 subjects, and we together will complete 8 subjects. Every day we will take 2.5 hours of class. Every day we will cover every subject, right? How it come and when we calculate. Yes, Praveen, it is a standard formula, so it is already being adjusted there, because 0.02. Why 0.02 is there? So when Indian Railway have derived that formula, they have already accommodated that. Okay. So guys, me and Abhinav sir are beginning a new series on Grade Up Gate channel, that is this channel, from tomorrow, where we are going to cover every subject. Every day we are going to take class at 4 p.m. Class length will be 2.5 hours. We are going to take lots of questions from every particular subject, because this is the time when you are going to practice more and more, right? So the name of the series will be the Grade Up mock test of GATE for civil engineering. The timing will be 4 p.m. from tomorrow. This channel only, okay? This channel only. So let's begin, guys. Let's begin the airport engineering. Are you ready with full power for this amazing session on airport engineering? All right. So guys, let's begin. Let's begin. I hope, okay, 102 likes we have covered. Amazing. Questions. Nivedita, questions. We are going to solve questions. 2.5 hours, and we are going to solve only questions. Just imagine the quality questions that you will get in those 2.5 hours. And obviously when me and Abhinav sir is there, dhamal hona is obvious, right? Also at 6 p.m. me and Abhinav sir are coming together on Grade Up Civil Champion YouTube channel at 6 p.m. Do not miss the session, everybody. Okay, we have a surprise also for you all. Let's begin the airport. Now before I begin this, let me tell you a few things, right? So guys, airport are classified by two organizations. There are two organizations which take care of all these things. So the first organization is ICAO, that is International Civil Aviation Organization. The second agency which take care of this airport thing is FAA, that is Federal Aviation Agency. These two names are important. In our highway engineering, which organization is very important? Everybody in the comment box, fire. Write down that name with complete fire. Which organization is taking care of everything in highway engineering? Most of the thing actually. The name please. Here, these two organizations are here. One is ICAO, International Civil Aviation Organization, and second is Federal Aviation Agency. Quickly respond, everybody. quickly. Yes, that is Indian Road Congress. Right. Next, based on the basic runway length, we have longest runway and shortest runway, equivalent single. So basically, these are the things which are going to be taken care by ICAO and FAA. But do we have to talk about them? No. We have to talk about one thing which is known as crosswind. Now understand what is crosswind. Okay. Let's understand what is crosswind. Suppose we have this runway here. This is the runway here. Everybody, please see. Suppose we have a runway here. This is not a road. This is a runway, everybody. Suppose we have a runway here. Right. Suppose if the wind is blowing from here. Suppose if the wind is coming from here. Right. Let's take one resultant wind like this. So guys, obviously it will have two components. This wind will have two components. One will be in this direction and one will be in this direction. Right. If this is the velocity of the wind and this angle is theta, this will be V cos theta and this will be V sin theta. Now, this V cos theta velocity of the wind is very helpful for us. If we are taking off, then also this particular velocity is helping us. If we are landing, then also this velocity is helping us. So this is our friend, very close friend. But this here V sin theta, it is always interfering in my action, whether I taking off or whether I landing. Taking off or landing, doesn't matter. But this V sin theta is interfering with both the actions. Both the actions are going to be interfered. Right, guys? Right. Now, this particular wind is known as crosswind. This normal component of wind is known as crosswind. Crosswind. All right. Okay. Now, there is one more thing, guys, which is known as wind coverage. Now, what is wind coverage? Now, what is wind coverage? Guys, understand the percentage of time. Understand the percentage of time during which in a year, percentage of time during which in a year the crosswind component remain within the limit. It is the percentage of time during which in a year the crosswind remain in the limit. That is known as wind coverage. So what I am going to do is I will check this wind coverage is less than the permissible value, is less than the limited value, and I will check in which direction I should make the runway. And that is done with the help of windrose diagram. This is the windrose diagram. As you can see, guys, this is telling you three things. This windrose diagram is telling you three things. What are those three things? Understand. First, it is telling you the direction of the wind. So in this direction, this much wind is here, this much wind is here, this much wind is here. So in every direction, you are getting different winds, right? Other than that, it is telling you the wind intensity as well. So these color are telling you the wind speed. So you can see the color and you can understand by that, right? Also, it is telling you that for how much percentage of time that wind is sustaining, 2%, 4%, 6%, 8%, 10%. So in whichever direction I will get the value of my wind coverage under the limit, I will provide my runway in that direction. Generally it happens in one direction, but in India there is an airport where we have two runways in two different directions. Can anyone tell me which airport is that? Can anyone tell me which airport is that? Please let me know, guys, which airport is that? Full power response. It is an Indian airport. What time it will be completed? It will take around 15 more minutes. 15 more minutes it will take. Okay, please go ahead. Thank you so much. Everybody quickly respond. Which airport in India having two runways in two different directions? Yes, that is your Maharana Pratap Chhatrapati Shivaji International Terminal. Yes, that is correct answer. The Mumbai airport is having two runways. As you can see, this is the Google image of your Mumbai airport, right? Can you see that there is this one runway, right? And then there is this another runway. Can you see that the runway is having different direction because the wind coverage was not sufficient in one direction. That is the reason why we have to provide two directions. Everybody felt it? Did you get the feeling of the concept? If yes, then let's move to the main thing, that is the question which will come from your airport engineering. This is the question which have been asked in previous year also, and by completing this you will cover the complete 10 marks of your railway and airport engineering, and we will close the class after this particular discussion. Right now, let's talk about the correction that we have to provide in our runway length. Right, there are basically three corrections that we provide: the correction for elevation, the correction for temperature, the correction for effective gradient. Right, one by one we will discuss about all these things. Okay guys, all right. So we generally assume that we are providing the this runway at mean sea level, but we are not. Obviously we have to provide the correction that time. So understand what is the correction for elevation. The correction for elevation, understand, the ICAO, I have already talked about ICAO, recommends that the basic runway length should be increased by 7% per 300 meter rise. As you move 300 meter above, you have to add extra 7% in your basic runway length. Guys, stay with me. This is the last concept. This is the last concept, and this is the most important concept of airport engineering. This has been asked in previous year also. This have been asked in previous year also. That is why I'm saying. Okay, so this is the first correction we have to apply, that 7% per 300 meter rise. Of what? 7% of your basic runway length. In the question, there will be basic runway length given. I will solve two questions for you. Next, correction for temperature. So standard atmospheric pressure, we have temperature we have to find out. First of all, with the help of this formula, 15 degrees Celsius minus 0.065 into change in elevation above mean sea level. Then we have to find out this ART. What is ART? Guys, ART is nothing but it is, can you please tell me what is ART? It is airport reference temperature, right? And once you have got the airport reference temperature, see here, it is TA plus TM minus TA by 3. TA is your monthly mean of average daily temperature. TM is monthly mean of maximum daily temperature. Don't worry, I will solve a question, then only I will close the class. So please relax. ICAO recommends that the basic runway length after corrected for elevation. First, you have to provide the correction for elevation. You cannot break the sequence. So corrected for elevation should be increased by 1% for every 1 degree rise of the ART above the standard atmospheric temperature. You have to check the temperature is how many degree above the ART value. And for every 1 degree, you have to increase it by 1%. Right? And guys, after that, we have to apply one correction. We have to apply one check. What is that check? I will tell you during the question. And lastly, for gradient, you have to provide after elevation and temperature, runway length should be increased by 20% for every 1% of the effective gradient. Now guys, let's solve the question with full power. Everybody, are you ready? Also, first two correction were given by ICAO. This one is given by FAA. This is given by FAA. First two corrections were given by ICAO. This is given by FAA. Right? Now let's solve the question to understand it, to get the complete feel of the concept. Understand. Basic runway length is given as 1620. ART is 32.94 degrees Celsius. Elevation of airport site is 270 meter. If runway is to be constructed with 0.2% effective gradient, calculate the corrected runway length. Let's solve this question. Okay. Let's first apply the correction. Let's first apply the correction for elevation. Correction for elevation. So the correction for elevation will be how much? 7%. 7% for every 300 meter rise. For every 300 meter rise. Here I have 270. For every 300 meter rise. This is what I have to get. Right? And of what? 7% of what? The basic runway length. That is 1620. So guys, this value will be how much? Correction for elevation. How much is this coming? It is 102.06. Right? So corrected length after this will be 1620 plus 102.06 meter, and that should be the value as 17. How much? Is it 22 or 21? Can you please tell me? It is 1722. 1722.06. 1722.06. Thank you so much. All right, everybody. So now if this is the length, very good. Now we will apply the next correction. And that correction is the temperature correction. First, let's get the value of the standard atmospheric temperature, right? So it was how much? Let's find that out first. So that will be 15 degree minus bracket 0.0065 into whatever the rise we have from MSL. So how much rise we had? We had 270 meter. So this value of temperature is coming as 13.24 degrees Celsius. Right? The ART value is already given to me. ART value is already given to me as 32.94 degrees Celsius. Now everybody tell me how much extra temperature I have above ART. Above ART, the temperature difference is delta T degrees Celsius is how much? 32.94 minus 13.24. So everybody, this value should be how much? This value should be 19.7 degree. So I have to add for each degree, I have to increase 1%. I have to increase 1% for each degree, right? So let's see. Correction will be, the correction will be 1% of the value which I have corrected for elevation already, 1722.06 into, for each degree I have to add, right? So I have 19.6 and I have to add for every 1 degree. So this value of correction will be as 339.24 meter. So everybody, the value will be, the corrected value will be after this, the corrected value will be 2061.3. 1722.06 plus 339.24, and this value is 2061.3. Till this point, anybody have any doubt, quickly please let me know. A small doubt, big doubt, any doubt, please let me know. I am waiting for you in front of you. Everybody quickly please let me know if you have any doubt. And now we will apply a check. Check is, we have to see the total increase in length. The total correction should not be more than 35%. Okay, total correction should not be more than 35%. That I will check. So let's see how much is the total correction by now. 2061 is the value. So the total correction is 2061. How much? It is 0.3 also, right? 0.3 minus 1620 divided by 1620 into 100. So the correction that we have applied is, how much it is coming, guys? 27.2. 27.2%, which is less than 35%. So the check is correct. The check is perfectly correct. Equal to also, if it is equal, then also it is correct. So check is correct. Now I can apply the third one. That is because of effective gradient. How much? 20%. 20% of this corrected one for every 1%, and I have 0.2%, right? So 0.2%. So from here the value should be how much? 82.45. If I am wrong, please correct me. If with calculation I am wrong, please correct me. I don't have calculator with me. I am relying on some solutions. So the corrected length will be 2143.75 meter. That is it. This is your final answer. Please tell me if anyone have doubt. If you have not liked the video yet, kindly please hit the like button, because we have discussed the complete railway engineering and the airport engineering in just 2 hours 30 minutes. The most important part actually for gate, again I'm telling, for gate, right guys? In this question, no, I don't have value of ART. Only one thing you have to do is you have to find out the value of ART. So ART value was how much? TA plus TA plus TM minus TA by 3, right? So I'll just directly put the values. Check. Okay, so the check that I have applied is, we have to see after application of the correction of the gradient, of the elevation and the temperature, we have to see if from the initial value, from the basic runway length, if I have increased my length more than 35%, then I have to go back to the site and check the values again. But if the correction is coming less than or equal to 35%, then it is correct. Then we can move forward and we can find the correction of effective gradient as well. Okay. Now the value of ART will be how much from here? It will be 15 plus 21. And this will be 17.2. Thank you so much, Abhay. So guys, 17 this is the ART, that's it. Rest, the whole question is same. Let me tell you the answer also for this. You can solve it by yourself. 2438 is the right answer. After all the correction, this will be the answer. Everybody, this sums up your session of complete railway and airport engineering. Quickly just hit the like button if you haven't liked the video yet. Also, please share the video with every friend who need this video, and also subscribe the channel if you haven't subscribed the channel. Now quickly tell me guys, did you enjoy the video or not? How SAT will come? Please tell. What is SAT? Subjective. Come on everybody, full power. How was the session? Did you enjoy it? And are you ready for another session at 6 p.m. on Grade Up Civil Champion YouTube channel? Me and Abhinav sir will be together in front of you with full power, with full energy like what I have right now. Everybody, full power response. Set a scene. एकदम कोई दिक्कत, कोई परेशानी. बहुत बढ़िया, बहुत ही बढ़िया, बहुत ही बढ़िया, बहुत बढ़िया. Thank you so much, Tejas. And guys, now please revise the whole thing again and then try to solve the previous year question and just get the value. Okay, standard atmospheric temperature. This is the value, no? I have told you here also. This 15 minus 0.0065 into change in elevation above MSL. So this here above MSL is how much? 270 meter. So this is the same thing which I have done. 15 minus 0.0065 into 270. 270 was the above MSL, right? Right? Hai, but it is not important, that much important. Ab hai. Agar aa gaya to there is a slight chance, but not very much. Okay. Right? So thank you so much everybody. I will see you at 6 p.m. with Abhinav sir on Grade Up Civil Champion YouTube channel. Everybody, I'll meet you there. Till then, agar aap logon ne अभी तक वीडियो को लाइक नहीं किया है, प्लीज वीडियो को लाइक करिएगा. दिस विल सिंपली टेल मी इफ द सेशन वेंट वेल और नॉट. एंड एवरीबडी, थैंक यू सो मच फॉर ज्वाइनिंग मी एंड थैंक यू सो मच फॉर बीइंग विद मी फॉर कंप्लीट 2 hours and 30 minutes. Thank you so much. I'll see you at 6 p.m. on Grade Up Civil Champion YouTube channel with an amazing surprise with Abhinav sir. So please be there. And now relax, solve the questions. You will not find any difficulty in railway engineering. You can solve the previous year question also and solve some questions from test series as well, right? So thank you so much everybody. I'll see you again. Till then, you have to do 2 things for me. 1, take care of yourselves, and 2, take care of your family, and just prep smart, stay safe, go grade up. Thank you so much everybody. Thank you so much.